So what you saw on Dan's slides this morning when he talked about Alexa, what we want to achieve with LabTwin is be the Alexa with a PhD. So let me tell you what and all about beating as a digital assistant is. So what I want to take you through is a little bit about the past, a little bit about what we think is pitfall in the current documentation process, then getting into real-time data capture, workflow assistant, and of course what Renee said, the future is now. So let's show. So what we see in the past is a lot of paper documentation. Paper documentation where lab assistants had the responsibility to helping the technologists and scientists during the lab research. They did the note-taking, they did everything that took it in from paper, but then there was a lot of manual process, of course, to put this into systems. Their duties were not, of course, only taking the note-taking, they were also, of course, processing examples, and why don't we use that to excel them? So, a little bit of the do's and don'ts in laboratory assistants. The left-hand side is the do's, the right side, of course, is the don'ts. But why can't we replace the do's with something that is digital? Why can't we replace something that you add voice to it and make sure that we are using notebooks, we are explaining those acronyms, we are encoding those things, we are attaching all the things that we do in real time at the bench rather than writing it down and then walking back to your office and then you start doing this. So why do we say voice? Because we are the digital voice assistant. And same way as you worked with your lab assistant in the past, you can speak to us. You can speak to us, and voice is not something new. Voice is already something very old because we all walked around with the memory recorders where we talked and entered all the data. But then in the end, it was manual transcribing it again. You have to listen back, hours of what you have spoken to, and then you have to put it back into your electronic systems. So combining this voice with the virtual assistant is what we are as a digital assistant. So we all have in our house probably an Alexa and Siri and any other of the devices. And maybe you have tried to talk science to those things. It doesn't work very well, right? It doesn't give you the right answers because it doesn't actually know science. A real personal assistant, by the way, is only limited, of course, to CEOs and personals that they hire up. And yeah, what the digital assistant can do for you is really the ultimate companion that you can take into your lab, helps you with your work, and then you take it back. So why are we addressing this space as a digital assistant? So what you see out there, if you're talking to your LIMS vendors and your ELN vendors, those mostly are residing into your office, right? That's where they use them. You can't really easily take it into your lab because it's very click heavy. You have to deglove so a lot of the times in order to access those systems. It takes up real estate that you don't have into your lab because sometimes it's just squeezed by space. So the current pitfalls of documentation we try to address with the digital assistants. It's real-time capture, so you don't need to use your hands. You can use your hands, as you see in the picture, for just doing the things that you need to do, science. That helps you, of course, increase productivity. It helps you improve traceability because it immediately goes from speaking to the system into your ELN. It helps you to remove that paper process that you still have in the LIMS, where you have sticky notes, or you write on your fume hood, or you write on your glove. And it also is taking away the manual errors once you're getting to enter it into your ELN. So how do we do this? Like I said, if you take your Alexa or any other Siri, it's around accuracy to that it understands what you're saying is around 75%. So what we're doing is we're training the model. So we have our base model, we have a scientific model, and on top of that, we have our individual terms. So the more you use it as an end user, the better the model gets. So it's trained to use, first of all, no science, but it also is trained on your individual terms that you are using in your organization. So that means that everything that you do helps you to get a better experience in the end. So the more you use it, the better it gets. And it gets up to a 95% accuracy And that's actually the same accuracy that we humans have when we interact with each other. So we do this, like I said, with a base model. We also train it on dialects, for example. So if you are talking English to it, like me, I'm speaking Dutch English, so I have a very different dialect than a native speaker, or an Italian speaker, or a French speaker. So we also train it on dialects. So again, so it improves the model and it gets back into your into your system the next time you use it. What we also do is really try to structure the data. So if you say a sentence, as you see here on the screen, we really want to label the things that we get out of it. So we're looking at the intents that we have. So if you say I, then it knows it's the person that speaks to it. So it's the scientist, and he did this at this particular time. If you UK, and I see there is an error in the font of the translation, but if you see the unit, so Michael, we created it, the quantity is there, the unit is there, the chemical is there, the protocol is there, and the location is there. So by labeling the data, what you're speaking, you can also have then extra metadata that it knows what you're searching for, and you can put it back into your So what we saw a lot of times is people that without using a digital assistant, there is a status of documentation. We did studies and we found out that only 20% is directly typed into the ELN. 80% is not even documented at all. And around 61% is just still described on paper before it goes into the ELN. That's a lot of data that can be lost, right? If you lose your papers, if you lose your data. So again, that's why we think that digital statistics can really help you reduce the risk. It gives you faster access, and it's 100% digitized at the moment you take it and you consider it. It's also, of course, taking into the deal of fair data. So what Simone talked about yesterday, like findable, accessible, interoperable, and reusable, because the real-time capture, together with the structure, the labeling of the data, is of course increasing the accuracy of the data collection. It improves execution, because what it can do, it can also guide you in the work that you do. So you can have your protocols, which are either living in your ELN or living into the digital systems, can give you guidance of what you need to do. So it tells you step by step, what do I need to do in the lab? It can, doesn't have to be, but it can be used this way. And of course, it's connected to the ecosystem. So what we wanted to achieve in the digital systems, like we did with the Revity integration, is really be part of the ecosystem that's out there. It's not our intent to build an ELN. It's not our intent to build a LIMS or replace it. What we want to do is be the front end, support the scientists where they needed to be supported, and that's at the bench level. So from another study that we did, so what we saw during a 2-week study that we did with customers is we saw the reduction of the workflow by around 25%. Because they were doing this, they did the manual transcription that they didn't do. The accuracy of the data improved by 85%, and the reproducibility, and of course the data loss. I think that's an obvious one. So actually, if we calculate this into our ROI, we can save up by 60% of an FTE. And we have data to prove this. It's not just a slide. We really have the data that can prove the statement that we do. So how can we get from that notebook state, paper-based state, into digital real-time capture? And you saw these pictures before if you saw the 5 minutes introduction, but I'm now going to explain you a little bit more. So what you can do is capture your observation to result anything in voice notes. That means that you speak to the digital assistant, and what you said is being transferred into notes, and that notes can be stored in notebooks. What it can also help you is create, for example, your method development. So what it can do is it capture all the notes and how you get to that result, how do you get to the observations, you report back to that, and that is a protocol that you can create, and that protocol can then be voice guided. It can do more than voice, because we are not voice only. We can take pictures, of course, because we have the mobile device or your tablet in the lab. We can annotate this with voice, so what did you see on that picture? But we can also use it to, of course, scan barcodes or QR codes that link you directly to your protocols or any other thing that you have in the lab. It can also scan labels. So we use AI to determine, for example, on a reagent, what is the vendor, what is the lot ID, what's the expiration date. So you document also that kind of information immediately into ELN. You can also use it, for example, if you want to get a balance weight, right? You take a picture of your balance, we take out that weight and we store that as a result. So then you have the actual proof, it was your picture, and you have the text that you have your results there. And you can document that. So there are many ways to use not only voice, but also your camera there. Of course, we also have tables, because sometimes you want to do a real results capturing in a structured way. You do want to do some calculations. But you want to do this by voice, because you don't want to click into the cells. So we added voice onto tables. It's not Excel. I already said this before. I want to say this really out loud. It's not Excel, but it gives you a lot of opportunities to do calculation. And what we can do is we can use your Revity tables, use that as tables in LabTwin, and then push it back to the ELN. So also that is an opportunity there where you can use tables with voice into your lab. We have a no-code protocol, creation and an editor, because sometimes your SOPs or sometimes your protocols are not even there, or they are not part of the ELN, or they exist in documents. What we can do is also there we leverage AI and ML to take the protocols from your Word document or your PDF and transform that into voice-guided protocols. So that means that you don't have to use it and click and build those protocols yourself. We use that, we read it in, we detect if it's a material that you want to have, or if it's a step, if it's a timer that you want to set, and then we create a protocol out of that. So that means then that when you have these protocols, you can really be guided step by step. So in your ear, you will hear the readout, or do I need to capture a result? Do I need to confirm that result? Because sometimes you want to have a confirmation that whatever you have read in or that you said, you also want to confirm before you go to the next step. It allows you to set timers. It allows you to set reminders that you are triggered on the phone that you have to get something out of your incubator, or I have to get some samples out of the freezer in 3 days. And it gets the notification. The good thing also here is that we can have a bi-directional integration with ELNs. That first of all, you don't need to don't need to build those protocols. If they exist in the ELN, we pull them down or in your LES system. And then, of course, every step that we have taken, we send back to the right section in your protocol that exists into the area. Another addition that we added is access to data with QR codes. So what we have been asked for a lot of times is, can we have a QR code on an instrument that gets us to the manual? Or can we have a QR code that access to how do I maintain an instrument? Or can I get access, because I always do the same protocol here on the bench, that I don't have to search for the protocol, I scan it and I can run it immediately. So QR codes, you can add a multiple of hyperlinks to the QR code, so you can also search whatever you want to pick and point, because sometimes the instrument, you want to have the manual, you want to have the maintenance, but actually you also want to really have the protocol that you are running on that instrument. So for your workflow assistance, what we can do and what we will show in the video is that you can push content to Revity. So as simple, the most simplest integration is that everything that you capture, you select and you push that into the Signals notebook. So on the left-hand side, it's the Signals notebook. On the right-hand side, it's our application. And what you can do then is, once you have captured your data, you can connect it to your Signals experiment. So we have a list of all the users' Signals experiments that they have. You choose your existing one. And in this particular case, what we send over is the report of a protocol that's being executed. You click consent, and then your whole report with every step that's captured, when it was completed, is now added to the last section of your Revity notebook. So from there you can of course then put it into the right place. Or what you can do is the other way around, is really target a section where you want to push. So for example, if I take a picture, what I want to do then is I want to select first of all the notebook, and the last one I've used is there. But then I want to select which of the sections do I really want to go into. So for example, the picture needs to go to the results. And what happens there, the experimental node and the picture is now into your notebook and does exist and live there, right? And again, with the audit trail, who did it and when did it happen, and also with the voice notes that are attached to it. With this integration, why would you wait? Because the future is now.
In the lab,
Hey LabTwin. Open protocol.
I'm using LabTwin.
Opening protocol blot cell treatment.
It guides me.
Step 1. Pipette 250 microliters of lysis buffer into each sample and mix well.
Step by step, through my experiment.
Add note.
I can record notes.
Sample 1 contains cell lysate contamination.
On the spot,
Add photo.
and take photos of my observations in their context.
Next step.
Step 6. LSB buffer dilution. Batch 1 volume, milliliter.
Sometimes,
2.
using a table is more convenient to calculate dilutions.
Batch 1 dilution factor.
100.
Batch 1 volume antibody, milliliter, is 1.98.
Next.
Step 7. Protocol complete. Would you like to send the protocol results to the ELN?
Yes.
And the best thing of the day is knowing that when I'm back at my desk, all my notes and pictures are already in my ELN and structured.
So what you saw here was a complete workflow being executed without using her hands. She was wearing a headset. The headset has the bone conduction, so there is not plugging their ears for safety regulations. The headset can be wiped, can be cleaned. And because it has the bone conduction, it also doesn't resonate to other people in the room. We can have different wake words so that it doesn't like Siri. If I call out Siri right now, probably all the phones go, right? We can have wake words that are different per analyst, so that also that it distinguishes. And what you saw here is that it was immediately from mobile, so without the interference of the web, the report was executed and was being pushed to the ELN. Of course, what you saw now was a very operational execution at the bench level. Where we want to go is really that LabTwin will be the companion of the scientist. When he wakes up in the morning, he knows what he wants to do, and he gets the information what he wants to do. So what we get questioned a lot of, for example, can you help me with answering some scientific questions, like molarity calculations, or molarity rates, or dilution calculations? Or when I have my hands busy, can LabTwin help me to tell me when is my next meeting? Or when I want to do my work, can LabTwin tell me where are my samples? So the next thing is, and that's really leveraging the large language models that we have around the world, what Michael talked about, and we want to transform that into the real LabTwin companion.
Porcupine, what's the molecular weight of urea?
The molecular weight of urea is approximately 60.06 grams per mole.
Porcupine, what's the boiling point of formamide?
The boiling point of formamide is approximately 210 degrees Celsius, 410 degrees Fahrenheit.
Porcupine, when is my next meeting?
Your next meeting is today from 3 p.m. to 4 p.m. with Dr. Sarah Patel in Office D.
Porcupine. Where is blood sample 1?
The sample is located in MP Lab 1, room 3 of the main building.
Porcupine. When was the electron microscope last calibrated?
The electron microscope was last calibrated on December 30th, 2022.
So, and here you see why we want to embed into the ecosystem, because you see examples, of course, having an embedding with Outlook. You see an embedding with a LIMS system, where is my samples, an inventory system about calibration, and of course with PubChem to really answer that scientific inquiries that you have seen here. It's not the future, so scientific inquiries will come out later this month, where we actually put this into production, so people can already use this, and we try this out. But what we wanted to achieve here is that also the support of the scientists can be anywhere, not only in the lab, where we support their execution. That was my talk, so are there any questions? A lot of questions.